So we have previously set the player up so we can see that the model in fact has a gun kind of built in. So let's go ahead and get the player to a point where the player can defend themselves. What we're going to do is we're going to give the enemy the ability to have health, and then we're going to give the player the ability to take that health away.
So we're going to go through the enemy health script next. So we'll start off by finding it in scripts enemy folder. And then we can drag and drop that onto the Zombunny in the hierarchy. So that's going to apply the script for us. On the Zombunny, so we can see that there's a death clip, which we're going to apply. Use the circle select button, and that's opened up the context sensitive menu, so we can find Zombunny death. Apply that. So now everything's set up for us. We can edit that script or view it and see what's going on in that.
So if you double click the icon to open it up.
So as always, we've got our public variables at the top, and very similar to the player's health, we've got starting health and a current health. They work exactly the same as the player. So the next one is the sync speed. So when these enemies die, it looks a bit funky to just have them lay there and then suddenly disappear. So what we're going to do is make them sink through the floor. So as soon as they've finished flopping over and dying, they sink through the floor, and that's how fast we want them to sink through the floor. Later on in the day, we're going to start doing scoring for this game, and so each enemy needs to have a score value, how much they increase our score by, and that is the score value. And we've got the death clip, what they play when they die. We've got some private variables, starting off with the animated component reference. Then we've got a reference to the audio source. We've also got a reference to the hit particles. If you remember, we dragged that on as a prefab and applied it as a child object. And likewise, we've got a capsule collider reference. Then we've got a pair of Boolean variables. We've got isDead, which works exactly the same as with the player, and isSyncing. So they don't immediately start syncing because we want to see their animation. So we need to have separate bools to determine whether or not they're syncing and whether they're dead. So next, we've got our awake function, which is going to set up our references as usual. So the first two, as we've seen before, get component, the type of the component that we're going to find, animator, audio source. But with hit particles, we need to find a component in the child object hit particles. So what getComponentInChildren will do, we'll go through all of the children game objects and then find the first particle system and return that. Again, we've got getComponent to find the capsule collider. Then at the end of the awake function, we're setting the current health to the starting health. So in update, all we're doing is we're checking whether or not the enemy is supposed to be syncing or not. If it is syncing, then we're going to translate the transform, and that means just move it. So we're going to move it in a negative up direction, down, and we're going to do that by the sync speed per second. So that's that times time.delta time thing. If we do that, then we're moving per second instead of per frame.
So just a quick note about translate. Previously we used move position to move this thing, but we're going to be no longer using physics when the enemies die, so we can go ahead and use translate without worrying about losing sync with physics.
So next we've got, again, a very similar function to the player's health. We've got a public function, so again that means it can be called from another function, and that's where we'll be calling it from.
Another script,
sorry. But this time we've got the integer of how much damage is going to be taken, but also the hit point. So where has it been hit? And we'll be using that hit point to move the particle system around the enemy so that fluff is flying out wherever it gets hit. Right, so the first thing we want to do in this function is check if the enemy is dead. If it is dead, then we don't need to do anything, so we're going to return out of this function. Assuming we are not dead, or the enemy is not dead, we can continue on with this function. Then, since we've taken damage, we want to play the hurt sound effect. We'll then lose the amount of health from our current health. And next, what we're going to do is find the hit particles, so that's the particle system, find the transform that that is on, and move that's position to the hit point. So we've got a child game object, we're finding that's position and moving it to wherever we've been hit.
So note that we haven't actually defined the hit point, but it's going to be passed into this take damage function using that second argument, this vector 3. So we're going to send it wherever we call take damage, and you'll see that a little later on.
Okay, so after we've moved the position of the particle system, we can then play the particle system so the fluff starts flying out. Okay, and last in this function, we're going to check if our current health is less than or equal to 0. If we've run out of health, then we use the death function. So the death function, first of all, we set isDead equals to true. Then we'll set the capsule collider to a trigger. So what that means is, because you don't actually physically hit triggers, if the player is running along mowing down enemies, then when they die, they won't become an obstacle anymore. It can keep on moving and keep on mowing through them. Then we set the animator trigger dead, so the enemy knows it's dead. It performs its dead animation. And lastly, we're going to set the audio source to play the death clip. So we change the clip that it's got to play to death and then make it play. Okay, so we've got a public function here called start syncing, and we'll discuss why it's public in a minute, but for now we'll just go through what it does. So in this, we're going to find references to the nav mesh agent and disable it. And then we're going to find a reference to the rigid body component and set it to isKinematic. So the reason we're going to set it to kinematic is that when you move a collider in the scene, Unity will try and recalculate all the static geometry because it thinks, okay, the level's changed, I need to rethink about this. But if you've got a kinematic rigid body and you're translating this object, then it will ignore it. So that's why we're doing that.
Real quick here. So we see get component nav mesh agent dot enabled equals false. So if we are trying to turn off a game object, we say dot set active, and then in parentheses say false. But nav mesh agent's a component, so we say dot enabled. So just keep that in mind. If you see dot set active false, that's a game object, and we're turning the whole game object off. Here we're doing dot enabled equals false. That means I'm not turning off the whole game object, just this one component of that game object.
Since we're starting to sync, is syncing is true. And lastly, we're going to destroy the game object after 2 seconds. So basically, it started syncing, it's going through the floor. After 2 seconds, we're not going to see it anymore, we can get rid of it, so we'll destroy the game object. And that's the end of that function, the end of the script as well.
When we're done with that, we can kind of hop back over into Unity here. All right, so the enemy now has health. And so one of the things that we want to do is we want to make the enemy's ability to attack dependent on whether or not the enemy is alive.
Sorry to interrupt you, Mike.
Oh,
I just remembered that we've missed something out.
Oh, sure.
So we had that start syncing function, and it was public, but we never called it. The reason we never called it is because it's on an animation event. So all these enemies, they have an animation event where they flop and then die. And what we can do in Unity is say, somewhere along the line of that animation, we're going to say, at this point, try and look for this function on the game object. Somewhere in the game object, there'll be a function called start syncing. So it'll look for that, and then if it finds it, it'll play that function.
So this was set up already. Yeah.
So, yep, this isn't something that you have to do. This is something that we've set up for you.
So this is something that's already there. Sorry about that. And basically, what this says is at this mark, which is something that's already in the animation, it's not anything that you guys have to do, it's going to attempt to call a method called start syncing. Now, up until this point, there has been no such method, right? But now we've created one, and we've added it. So now it knows I have a method called start syncing, and that will happen when this time comes, all right? Normally, if the animation were to play and that function were to not be there, you would get an error saying, hey, I'm trying to call this function and one does not exist. We did not get an error because we have yet to have any way of killing the enemy. So if we had, we would have seen an error, but since we don't, we did not see an error. So basically, yeah, so the function was public, and so this animation will automatically call that function when the time comes.
Yeah, so animation events are really useful. You can use them for all kinds of things. A real common use would be footsteps, if you had a single function to call a footstep at a particular point in an animation, because obviously you can pick a particular frame where you want this to happen. We've got this fairly roughly placed, and it just means that as soon as he kind of leaps up, we'll start sending him down as well as his kind of falling animation, which actually means that we're not actually getting the bounce on the floor. But we could move it along if we wanted to, but we're not going to bother doing that. You can play around with that later on.
Okay, so now that we have the enemy health script, it's important for us to pair the enemy attack script to that so that the enemy, again, does not attack once they're already dead. So what we'd like to do is we'd like to edit this enemy attack script to sort of uncomment those lines that we previously saw commented. Now, we could locate the script in the project view and double-click it and open it, but I just want to run through another way that we can open that script, right? So what I'm going to do is I'm going to go ahead and click on the Zombunny, and I am going to find the enemy attack script right here, the enemy attack script. And of a script component, the first property is always the script itself, right? So every script component has a first property called script, and the value of that is itself. And so if I click on it, what it does is it highlights for me in the project view that script. So I'm like, hey, which script is this? You click on it, there it is. But I can then double click on it here inside this property, and it again will open up inside MonoDevelop. So that's another way to open this script up. So this is now a part that you're all going to want to follow along with, because we're now going to remove this commenting while we explain what the comments were for. All right, so I'm going to come all the way up to the top here, and the first bit of commenting I see is a commented out variable that references enemy health. Obviously, we had to comment that out before because enemy health didn't exist on the enemy yet, so we had to keep that commented out. Now we're going to uncomment it so we can now have a reference to the enemy health script. Next, we're going to go to our awake function, and again, since we have this variable, we now have to get that reference, and we do that by saying enemy health equals get component, and the component name is the name of the script, which is enemy health. And then we're going to come down here towards the bottom, and we're going to notice this. And this is not the commenting you've seen before. There we go. It's about as close as it's going to let me get. So what this is called, this is a block comment. And what block comments enable me to do is comment many, many, many lines or pieces inside a line or whatever, right? So what we have here is we have what's called a block comment. And we can see that here's the start of the block comment, and here is the end of the block comment. So it's forward slash asterisks all the way to asterisks forward slash. So anything between there is commented out. And you'll see that this parentheses is not commented out because only the things between the block comments get commented out. So what we want to do is we're just going to go ahead and remove the block comment. So when we start to remove this, we'll see everything gets commented out, and then now nothing's commented out. So what this line says now, if you recall previously, it says, hey, if it's time to attack and the player is in range, we attack the player. Well, there's one more step, one more decision we have to make. We have to say, if it's time to attack, and the player's in range, and we're not dead, and at that point, we attack. So now, at this point now, with all of that stuff uncommented, now the enemy will attack the player correctly like they had been, and they will also stop when they're dead, which is obviously an important part of this whole dynamic. So be sure to get that stuff done. When you're finished with that, be sure to save the script and return, which will bring us back into Unity. Bless you. So the enemy is cool. We can leave the enemy alone for now. So now let's go ahead and get the player ready to rock and roll. And so there's a few things we're going to want to do. So the player already has this mesh, and the mesh has a gun, right? So the player's already set up with his weapon of choice. And so what we want to do is we want to make it behave appropriately. So there's some stuff we're going to add to it. The first is we're going to add a particle component, which is going to enable the gun to spit fire, right? Which is kind of makes it fun. We're also going to add the ability for it to have sound, right? So we can hear when the player's firing. We're going to add a light so that the player illuminates the scene when firing. And then we're going to add a line renderer. And the line renderer is actually going to be that line that we're firing out, right? To make it look like we're firing bullets or lasers or whatever. And all of these things are going to make this a much more fun look and feel to the game. So what we're going to do is we're going to go to the prefabs folder and we're going to locate gun particles. Now, unlike the hit particles of the enemy, we are not going to click and drag this prefab anywhere near the player. Instead, we're going to copy a component off of it. So we're not going to use this prefab, we're just going to use a piece of this prefab. So if we look over here in the inspector, we see the particle system that is a part of that gun particles. And I can click the cog or gear right here, and I can select copy component. I'm not actually interested in the game object or the prefab. I'm interested in the component that's on it. Once I've copied that component, I'm going to go to the player in my hierarchy, and I'm going to expand it. And I'm going to look for gun barrel end. Since the player has a collider and the player has all these pieces and parts, I'm actually really interested in the tip of the gun so that I can align bullets and everything with the tip of the gun and get shooting to happen the way we want it to. So with gun barrel end, not gun, not player, gun barrel end selected, in the hierarchy, I need to locate a cog. There's always a cog in the upper right-hand corner of the transform component. And I'm going to click that, and I'm going to select Paste Component as New. And there's my particles. So at this point, the particles are on the end of the gun. Now, they're not set to play. We're going to use scripts to say when those particles should start firing off. So now that we have the particle system on the gun, all right, so now let's go ahead and we're just going to minimize the particle system here by just clicking the little arrow next to it, just because the particle system itself takes up so much space. So we're just going to sort of collapse that down so that we have some room to work. So we have our particle system, and the next thing we want is we want a line renderer. The line renderer is going to be the visual component of shooting. And we're going to add that by going to Add Component, and I'm just going to type line in here and find line renderer. I'm specifically typing in line because I can't remember where it is otherwise. Now we have a line renderer appears as a component in our game object. And so what the line renderer is, like I said, it renders a line. And so there's some settings we got to do because as we can see right now, that doesn't really look like a bullet and that doesn't really look like a gunshot. It just looks like a giant magenta block. And so we need to set this up appropriately. So the first thing we're going to do is we are going to expand the materials dropdown. And you can see here, I can just expand that by clicking the materials dropdown. And I'm going to look for this element 0. And right now, the reason this is that hideous fuchsia color is because it doesn't have a material. It doesn't know what it's supposed to look like. So what we want to do is we want to give it a color. So what we're going to do is we're going to use the circle selector. We're going to click on that. And we actually already have a material created. And it's just a basic line renderer material, which we have cleverly named line renderer material. So if you use the circle selector and look through that list, you should find a line renderer material, double click on that, and that will apply it to the gun. Now, what we want to do is we want to go ahead and manage this line render a little bit better. As we can see, it's still, while it's a better color, it's the color of kind of like our laser, it's still way too big, so we definitely want to manage this. So what we want to do is I'm going to go ahead and collapse materials back down since we're done there. I'm going to expand parameters, and there's two things I'm interested in. The first is start width, and the second is end width. And what we're going to do is we're going to set these up to be the same value. Because of the same value, the laser will be a consistent size. If they were different values, it would either flare out in a cone or narrow in or whatever. And so for each of these, we're going to specify 0.05. That's not 0.5, that's 0.05. We're going to do that for both the start and the end width. Once that is done, we are going to go ahead and disable this component. And the way we're going to disable this component is with this checkbox right here, right next to the name line renderer. We're going to turn it off. And the reason we're going to do that is the game doesn't start with you shooting. The game starts with you not shooting. So we're going to turn it off and only turn it on once the time comes that you have actually fired. Now, when we fire the gun, what we want to do is we want to have the gun flash and light things up, right? In order to do that, we need a light. So I'm going to go ahead and again collapse line renderer, and now I'm going to add a light component. So I'm going to click the Add Component button, and I'm going to go to Rendering, and I'm going to select Light. And what that's going to do is it's going to add a light to my gun, which we can see there. And what we want to do now is we want to give this the settings that will be appropriate to this particular gun. So the first thing we're going to do is we're going to choose a color. And we have this little eyedropper. We can use the eyedropper just like you would expect an eyedropper to pick a color out of something. Or we can just click next to it and actually use the gradient/color picker to pick a color. I'm going to pick a kind of a yellowish color. If you want to pick a different color, go for it. But I kind of want my light to be the same color as my line renderer, so I'm going with yellow there. And so now, when we fire the weapon, there will in fact be a yellow light. Now again, like the line renderer, we're not starting firing, so we're going to disable the light. So we'll just uncheck it there, and the light will be turned off until we turn it on when we fire. And so the last little bit we are going to add is we need an audio source so the gun can play the firing sound. So what we're going to do is we're going to click Add Component. We're going to choose Audio, and we're going to choose Audio Source. Now, once the audio source is on the game object, again, just like we've done in the past, we're going to use the Circle Select Picker, and we're going to locate, I believe it's called Player Gunshot. Double-click to add that, and we are going to uncheck Play on Wake. We also very, very want to be sure that we do not have loop, because that will just drive everybody nuts. So no Play on Wake, no looping. That would be completely unnecessary. All right, so at this point, the gun's set up. So now we can go ahead and add the scripts that's going to allow the player to attack the enemy. So just kind of to recap, the enemy has health. We've added the health script to the enemy, which will control when the enemy can attack and how the enemy dies and all that stuff. The gun now has particle effects, lights, line renderers, and sound. Now the last piece of this puzzle is to give the player a script that's going to allow the player to actually fire the gun and harm the enemy. And so what we want to do is in the scripts player folder, we're going to look for the player shooting script. And just like the previous scripts, we are going to click and drag this. And we are going to place it on the gun barrel end. So we're going to place it on the gun barrel end. So not on the player, on the gun barrel end. So if we select the gun barrel end, we should see the player shooting script there. So again, ensure that it is not on the player, it is on the gun barrel end. And then let's go ahead and open up the player shooting script, save your scene first, and let's look at what this script does. The first thing we have, just like always, is we have these public variable declarations here. So the first is public int damage per shot. And we can see that every bullet is going to do 20 points of damage. We also have a public float time between bullets, which again is going to control how quickly our gun can fire. Obviously, we reduce that value if we want our gun to fire more quickly. And then we have public float range, and that's how far our bullets can go. And in this case, they're going to be able to go 100 units, which is actually a really, really far distance. Then we've got some private variables here. The first is a float timer. And the float timer, just like with the enemy attack, is just going to keep everything in sync. It's going to make sure we can only attack when the time is right. Then we have a ray, shoot ray. If you recall, we have a gun. We're firing, so we're going to use this ray to actually raycast out and figure out what it is we've hit with these bullets. And that's how we're going to actually hit those things. We then have a raycast hit variable called shoot hit, which is going to return back to us whatever it is that we've hit. We're then going to have an int shootable mask. So we remember the floor mask, which dictated that the raycast from the camera could only click on the floor. So what we're going to have is a shootable mask to make sure we can only hit shootable things. You know, we only want to shoot things that we can actually shoot. Then we have a particle system reference to gun particles. You'll recall that's the particle component that we added in our previous step, so that just gives us a reference to it. Here's our reference to our line renderer called gun line. All right, so again, just so we can reference this in script. Our audio source reference called gun audio, our light reference called gun light, and then our float effects display time, which is how long these effects are going to be viewable before they disappear. Now, in our awake function, we're going to set up all of our reference. So the first thing we're going to do is we're going to set our shootable mask to the appropriate values by saying layer mask.getMask shootable. What this is going to return back to us is the number of our shootable layer. You'll recall the level, all the obstacles and everything are on the shootable layer, and the Zom bunny we created is also on the shootable layer. So by setting up this mask, we can shoot pretty much anything that should be shootable. Then we have the gun particles, which we're going to get access to by saying get component and then particle system. And then we're going to do the same for line, audio, and light, just gun line, get component line renderer, gun audio, get component audio source, gun light, get component light, which is just giving us a reference so we can directly access those. Now, in the update function is where we control whether or not it is time to shoot. So very much like with the enemy attacking, here we have a function that's going to manage that. So the first thing we're going to do is we are going to accumulate our time. And we do that by saying timer plus equals time.delta time. So it basically will increase in size as time progresses. Then we're going to say if input.get button fire1. And you might be thinking, well, what is fire1? Remember earlier when we talked about the input get axis horizontal, input get axis vertical, these input axes that are built into Unity for us. Fire 1 is one of those. Fire 1 automatically maps to the left control on your keyboard or your mouse 0, which is your left mouse button. So that happens for you automatically. You can override it here, but if you don't do anything, that's built into Unity. So you can always say Fire 1, and that's how you talk about the left mouse button. So we're saying basically is, hey, if the player has clicked the left mouse button or pressed the left control key and timer is greater than the delay between our shots. So if it's time to shoot and the player wants to shoot by clicking the button, then we're going to call a function shoot. Shoot is a function we've written further down, and we'll talk about that in a second. So basically if it's time and you're pressing the button, we're going to shoot. Then we're going to say, hey, by the way, if the timer is greater than or equal to the time between bullets times the effect display time, what we're going to do is disable the effects. So what that means is if we fired and then enough time has progressed, we're going to turn the light and the line render and everything back off so we don't leave it on consistently. So the disable effects function is public, which means, again, it can be A, referenced by another script, B, referenced by another script on another game object, C, accessed by animation events, and so on and so forth. So public basically gives us a lot of access to it. And the function basically says, hey, the light and the line renderer, just disable both of those. Again, not set active, but enable equals false because they're components. Now, the shoot function itself. All right, this is where we do the physics of actually firing the bullet, and this is actually a fairly complex function here. So we'll step through it nice and easy. The first thing we're going to do is we're going to reset the timer. Back to 0 because we're firing now, so we're going to reset the amount of time we have to wait between firing. The very next thing we're going to do is we're going to play the audio. And then what we're doing is we're turning the light on. Now, we don't really need to do anything with the light or the audio. We just basically need to say, hey, go. Then what we're going to say is, hey, if the particles are still playing, stop them, and then start them again. What you don't want to happen is you don't want to go to play the particles, them already be playing, and so thus they don't replay, and we get a disconnect between the visuals of firing a gun and the actual raycasting and physics that's going on. So we basically say, hey, if the particles are playing, stop and start again. Also, if that were to happen, the stop and start were to be so fast, your eye won't even pick it up. It will just feel like you're just firing really fast. Then what we're going to do is we're going to say, hey, let's turn on our line renderer, which is the actual visual element of the bullet. So we turn that on. So we say gunline.enabled equals true. Then here comes kind of the tricky part about using lines. Lines have 2 points, right? One end and the other end. Well, the first end we know. It's the end of the gun. It's the barrel of the gun. And so we access that by saying gunline.setPosition 0. Computers start counting at 0. So when we say set position 0, we mean the first position of the line, which is right at the barrel of our gun. Okay? And so we specify that as transform.position since the script is on the barrel of the gun. Okay? So that's the first point. Well, what's the second point? We don't know yet. That's the part we need to calculate. And that's the part that requires a bit of physics and a bit of raycasting. So if you'll recall, we created a variable called shootRay, which is the raycast from our gun. And so the first thing we want to do is we want to set up this ray so that we can utilize it. The ray is going to start at the tip of the gun. So ray.origin equals transform.position. That's where the ray is starting off. Now, a ray starts at one point and goes in some direction. So we need to specify a direction for our ray. And we say shootRay.direction equals transform.forward. And this is something James actually talked about previously. We generally treat forward in the z-axis as forward, positive z-axis and forward. So as the gun is pointing directly away from the player, that is forward. So if I say transform.forward, what I'm saying is that way. Right? And so that the bullet will travel directly along the line of this gun barrel and this gun. Right? So we have a ray set up at the tip of the gun that way, right, forward. So now we need to actually use physics to fire it. And so let me kind of tell you what's going to happen, and then we'll walk through the actual code. The idea is that we're going to fire a ray forward, 100 units, because that's how far we say we can fire it. If it hits something, whatever it hits is going to be returned back to us, and we're going to say the other end of the line is there. Whatever it is we hit, that's the other end, and we draw the line. If we don't hit anything, we still want to fire, But if we don't hit anything, what we're going to do is we're going to say, well, where's the other end of this line? It's just way out there. And it's actually such a long line that there's literally no way to see the end of it. So you just think, oh, cool, he's just firing, right? You don't really notice. So we basically need to say, shoot a ray. If it hits something, that's what we hit. And if it doesn't, then just draw a really long line. We do that by saying if physics.raycast, so this again is that raycast function, and we're passing into it the ray that we specified. We're saying that way. And then we're going to say, hey, give us information about what it is that we've hit. And that's why we have this out keyword and then the shoot hit variable. If we hit something, the variable shoot hit will be like, this is what you hit. Cool, we need that information, so it's important to have. Then we specify the range, and the range is 100F. It's something we specified up at the top. It's a variable. And then finally, we pass in our shootable mask, meaning this ray can only hit the things we want this ray to be able to hit. Shootable things, right? We're not interested in anything else. If that ray hits something, we're going to go into this code. If it hits something, right, what we're going to do is we are going to get from it the enemy health script. I'm going to talk about that here in a second. So basically what we're going to say is shoot hit is going to have whatever it is we hit. We know we hit something. So we're going to say shoot hit dot collider dot get component enemy health script. So whatever it is I shoot, I'm going to say give me your enemy health script and I'm going to store it. We need the enemy health script so we can reduce the life of the enemy, right? But what if we shot a wall or the ground or some Legos? Those do not have an enemy health script. Those are not able to have health taken away from them. So if we attempt to access that enemy health script right away, it's not going to work, and we're going to get an error, and the whole thing is going to stop working. So what we need to do next is we need to say if the enemy health script does not equal null. This is specifically in here to show you that this function will work even if that component does not exist. It's just going to give you null, and null means nothing, right? It means one does not exist. So now we need to check it. We need to say, hey, by the way, if that actually exists, we're going to do enemy health dot take damage. We're going to pass in our damage per shot and exactly where we hit it. That's the really nice thing about raycasting too, right? Instead of just having a generic effect, if we shoot on the shoulder, that's where we hit it, the shoulder, right? If we, wherever, and we get to put the effects exactly where we hit it, which is pretty neat.
So if you remember in the enemy health script, take damage, if I just jump back to that very briefly, we can see that there is a vector 3 hit point. So you can see that take damage here needs to have a vector 3, needs to have a position in order to move the hit particles to where they need to be. So in player shooting, that's exactly what we provide using that raycast.
All right, so whether or not whatever we shot has an enemy health script, regardless of whatever it is, we still hit something. And thus we say gunline.setPosition1, meaning the second point, and we pass in that point that we hit. So whether we're hitting an enemy or the wall or some Legos or whatever, we now have our line. The beginning of the gun to the object that we hit. One line.
When we were kind of prototyping this game, we just had the raycast shoot by 100 units, but then we decided actually it makes more sense if the gun line stops at that point. We could expand upon the idea to have effects like ricochets and things like that, but we didn't want to get too bogged down. So actually what this is doing is just saying, okay, well if we hit something, then we end that line renderer's second point, or its end point, at the point at which the ray hits. So when we shoot a bit of the environment, it's going to stop at that point, likewise with the enemies.
Cool. So all of that happens if we hit something. What if we don't hit something? Well, that's our else. We're just going to say gunline.setPosition1 again because it's the second point, the second part of the line. And what we're going to say is we're going to say shootray.origin, so where the ray starts, plus shootray.direction times its range. So what effectively that's going to mean is it's going to take the point, and then it's going to multiply 001, because that's forward in the z direction, by 100, which is the range. And it's going to say this point, and then just take it way down there, and then that point, and it's going to draw a line. So it's just real simple. It's just say one end, the other end, we're going to draw a line between it. So a lot of physics stuff in there, but basically we're just attempting to point at something, and if we're successful at pointing at something, we're going to draw a line to it and take damage from it. Otherwise, we're just going to draw a line.
So the else there effectively is giving us the ability to shoot in a direction if we don't hit something on the shootable layer. So if you remember that the level is effectively a box, if you're aiming around in the other direction and you're effectively raycasting off of the screen, you still want to see the gun fire. So we're just giving it a range of 100, which is outside of the camera frustum, the view that you can see. So we're just spraying bullets around even though we don't hit anything.
So what we're going to do now, now that the gun barrel script is on there, let's go ahead and save our scene if you haven't saved your scene in a while. Now, with the player selected in the hierarchy, we're going to look at the apply button in the upper right-hand corner. So you recall we clicked and dragged the player and turned it into a prefab, but the prefab that we have on file is now slightly different than the prefab we have in our scene. The one on file doesn't have all the changes we just made. If we would like to update the one we have on file, we have to click the apply button in the upper right-hand corner. That will apply all of the changes we've made to the copy we have on file, thus saving it, if you will.
So the way that you notice the difference between a prefab and a prefab that needs updating is that some things will appear in bold. So if you note the difference between player movements properties and player health, which is added after that we made it into a prefab, you'll see that these are in bold. And when I update or apply the changes and look back down, some of them change. So the things that are still bold are things that are in the scene. So now we know that's up to date. We can carry on using it in other scenes. And if there are instances of this prefab elsewhere, then you would see those changes are automatically applied.
All right, so let's go ahead and everyone turn your volume down because we're about to test this.
Cool. Let's see how hopefully loud it is.
Oh, yeah. That's what I'm talking about. That's an American gun right there.
So just to reiterate, do not worry about this error that you will see appearing at the bottom of the screen. It's deliberate. This actual mistake is a genuine mistake that we want to show you how to fix. What you will notice is that at the bottom of the screen you have an error. So just to give you some insight on catching errors in Unity, so sometimes there'll be a compile error in that you've written something wrong in a script and the bottom of the screen will show you where and what in that script has happened. And this is all contained within the console. So if you go to Window Console, you will see that there are a lot of errors saying all about the same thing. Set destination can only be called on an active agent that has been placed on a nav mesh. So remember that the word agent is referring to the enemy. So the enemy has that nav mesh agent component. And set destination is the function of code that we used to tell it to seek out the player. So we said nav.setDestination player.position. So what is actually happening there is that there's a problem in our enemy movement script. So what we can do is double click on that error in the console. So just watch that one more time. I double click that and it takes me to what's causing that error. And if you recall earlier, we mentioned that there are some bits of code that are commented out that are disabled currently in this.
So when we first made the enemy chase after you, we didn't have a concept of the enemy's health or the player's health. So having those things in our script wouldn't have made any sense. So now we do have those things. The player can be killed or the enemy can be killed. And if it is, then setting its destination on the nav mesh doesn't make any sense anymore. So it's creating an error. So now what we can do is we can bring back those references to the enemy's health and the player's health. And every time we do an update, we want to check if both the player and the enemy are alive before we say set destination. Because if they're not, then we're in trouble.
I'm going to use a shortcut here I will teach you, which is command and /, which is a way of commenting out an entire line.
That's control / for your PC folk.
Yeah, for PC. And we can do all of this at once. So we've re-enabled this if statement and else structure around this to just check those different scripts. So it's checking the enemy's health, it's checking the player's health. If they're both more than 0, then it should keep trying to seek out the player. But if they're not, then we switch off that nav mesh agent. So the error that we were having in Unity is saying that set destination is effectively invalid. And we're solving that by checking if the player is actually there to do it. And likewise, if the enemy has enough health to be moving around. If not, we switch off that component by using .enabled equals false. So uncomment those lines in enemy movement, save the script, and then return to Unity. So basically, all of enemy movement should now be enabled. You shouldn't have any comments in it at all, and that should get you to the same point as us. Okay, so the last part of this is to look at the player health script.
So what we're going to do is reopen the player health script. So if you double click on it,
So go into Scripts Player.
double click on the icon for opening it, and you'll see that on the player's death, we've got some commented stuff here. So we want to be able to put that back in so that when the player dies, he can no longer shoot his gun. But we haven't got our references to player shooting yet.
So what it's saying, because it's turning red, it's saying, I don't know what player shooting is, and I don't know what disable effects is. It can't find the reference to that, so it's turning red to alert us that there's a problem. So on line 19, player shooting, reference to the player shooting script, which we've named the same. So this can cause some confusion. We've got player movement, player movement. Remember, this is the type, which is the name of the script, and this is the name of the variable. Names of variables can, of course, be anything you want them to be, but if I name player movement blah, I will have to write blah anywhere else. But we're not going to do that. We've named it something sensible, which means it's going to sync up with the other instances and work.
So the last thing we need to uncomment is the get component in children for player shooting, because remember that the player shooting script is on the gun barrel end, it's not on the player, so we need to find that component in the children. And now we've got our references, and we've already uncommented the codes about shooting when dead.
No longer red.
So it should all work.
So if you make sure that you save your scripts, very important, and switch back to Unity, and you can then go ahead and play and test your game. Now we can kill them. There's no more error about the nav mesh destination.
It's a very easy game. One enemy.
And we can also be killed by them. So that is the end of phase 7.